Yes? Is it on? Oh, no. Okay. We're filming for the people at home, but also for you, so that you don't forget. We're going to be looking at energy changes. Okay? Specifically, we're going to be looking at things called endothermic and exothermic reactions. Now, exothermic and endothermic reactions are really awesome, okay? They relate to energy changes within an actual reaction, and we're going to be demonstrating those two ideas before we talk about notes today. Okay, if you're at the back and you can't see, you can stand up and just stand a little bit closer so you can check it out. As long as you distance yourself nicely, it's absolutely fine. Of course, DR, please come closer. Bring your chair. Come, you can sit right here if you must. I don't mind. All right. Okay, so what I have is I have some distilled water. Okay, so the first reaction that I want to do is I want to show you an exothermic reaction. And exothermic reaction is one where heat is given off to the surroundings. That is the definition for an exothermic reaction, whereby we have a situation where there is surplus energy, and that surplus or extra energy goes to the surroundings. In this instance, our surroundings will be our water molecules. Okay. Now, what we're expecting to see is a temperature spike. Let's do this. What we're expecting to see is a temperature spike for our solution of acid that we're going to create. By temperature spike, I mean we're expecting the temperature to increase quite dramatically. The first thing I'm going to do is I'm going to allow the thermometer just to acclimatize and to get the temperature of the water, which should be very close to room temperature. That kind of makes sense. The bottle's been in the room, so the water in the bottle will be the same as the room temperature. Are we okay with that? Okay. Now we're going to describe where this energy comes from in a minute. Okay? For now, we're just going to have a look at what the energy actually is. Whenever we do an experiment with acid, we have a couple of things, a couple of rules that we have to adhere to, because acid is safety critical stuff. Okay, so the acid that I'm using is concentrated sulfuric acid. That means that it will create a chemical burn on your skin. All right, a chemical burn is not something that you want, firstly, but also it's not something that you expect. So a lot of the time when you think of a chemical burn, you're thinking of the flesh pulling away from my bones, yes? Or my hand just dissolving. Chemical burns are actually not quite so dramatic. What will happen is my hands will itch if I get some acid on it, and I will get an irritation depending on how much acid I've got on my hand, how long it's in contact with, all right? So I'll get a rash, or I'll get some skin damage, all right? But it's not going to be as dramatic as you would imagine. Okay, the rule is with acid is that if you get some on your hands, you rinse. Okay, that's the first thing. You rinse with water. So if we're ever in a lab situation where we're doing a prac and you spill acid or any chemical on yourself for that matter, the first rule is you rinse. So that means that you get to a tap before you start screaming. Do you understand? You have your hand, once you have your hand underneath running water, that is when you're allowed to start being dramatic. Do you understand what I'm saying? You have to spend the first part being smart and getting rinsing happening, and then you can be a drama longer. Okay, now I have my acid. It's in this thing called an acid tray, and that is to protect my cupboard inside and to make sure that the acid doesn't leak. You know, sometimes there's spillage on the side of a container. Okay, so we have an acid tray at the bottom, and that's because this is concentrated sulfuric acid. The next rule, we always add acid to water. The reaction is violently exothermic. This reaction is violently exothermic. What that means is that there is a massive temperature spike immediately. If I add water to the acid container, it will explode. Alright? Which is all fun and games until I have to explain to your parents why you don't have one eye anymore. Okay. All right. I'm filming this, right? Great. I'm going to need an assistant. Please come up this way. We need some eyewear for you. Do you want a visor or do you want glasses?
Glasses, please.
Glasses. Why don't you grab a pair of glasses from the back? Okay. So I have a temperature reading of around about 10 degrees. That's how frosty it is inside of the classroom. Okay? For those of you at home, I hope you're warm. Okay, so we have our temperature of 10 degrees. Come on, Aaron. You're going to hold this for me. Okay? And we're now going to add acid to water. A to W. That's the rule. A before W, like alphabetically. Always. Tuck that somewhere. It's a big deal. If you do it the other way around, alright, it's dangerous. I know you're thinking, yay, let's see what happens. I know you're thinking it. But what happens is the acid actually spits. So because of the fact that the reaction is so violent, the acid actually shoots up at you because of the reaction, which is really, really dangerous, which is why eye care is so important. Yes? Safety first, whatnot. Ready? Alright. Can you see where the red line is? Can you just watch the red line for a minute? Okay. Can you see it? Can you see the red line? It's at 10 degrees, which means it's down there. Are you watching the red line, Roman?
Yes, ma'am.
You sure? Can you see it on the screen?
My thing is...
Wow. What's going on? Okay. It's just not. It's not focusing. Okay. I think we can almost see the red line now. Just turn that slightly.
Can I get a visor?
All these things. I just want to protect your eyes, that's all. Okay. Ready? Okay. So, turn this on so that the camera can see the red line. Can the camera see the red line? Okay, so the line is about there. Okay? Okay, I don't want to sit over it because it's going to give off fumes as well. What's the red line? Check, check. Whoa, wow's his trousers. What temperature did we get up to? 75 almost, hey? Almost 75 degrees. From 10 degrees to 75 degrees, guys. 10 degrees to 75 degrees. 80 actually. It's on 80 now. I just want you, does anybody want to come and have a feel? Wait a moment, careful. Go.
Now, what happens if you put out?
How hot is it? Can you see it steaming? How close is that? Can you see the steam coming out of the beaker? The side of the beaker is actually steamed up. That's how hot it is. Press pause for me. Okay, so second type of, are we good? Second type of reaction we're dealing with is an endothermic reaction. Heat is taken in from the surroundings, okay? So the reaction itself doesn't have enough energy to give outward to the surroundings. Now we're going to pull energy in from the surroundings. So we're expecting a temperature decrease. I don't know if this is going to work today because it is already quite cold, okay? But we have a temperature reading of just over 10. Would you agree? Can you see it? Won't you hold that for me? Alright, we're now going to add a salt. Okay, and we're adding something called ammonium nitrate. I'm not expecting the reaction to be as dramatic as it was before, but I am expecting some sort of temperature change. Wow. Okay, don't you think? Okay, we're gonna swirl. I might have been a little bit too generous. Just say never, man. Never. And we've got a decrease in temperature happening. Okay, so we started at 10. Am I close? How's it going? And as I do this, I can see the temperature drop. It's almost at 5. Okay, can you see? We got 5, we got 4. Can everybody see the red? I'm just going to walk around so that you can see the red. It started at 10, and the temperature is decreasing as we speak. It's nearly on zero, in fact. I'm not expecting it to go very close to zero. But that's pretty phenomenal. So I've got a nearly 10 degree difference in temperature just by adding some salt. You see it? Okay, so just to finish up, we can see, let me just, there we go. So we've got it close to zero on the temperature scale. Okay, which means I've decreased the temperature by nearly 10 degrees. Nikolai, I need you to just touch the bottom and tell them that it's just hold it nicely. Tell them how cold it is. It's ridiculous. Hey?
Can it freeze then?
It's not going to freeze. It's very close to zero. It's about, what's that, 2 degrees. So it stopped at about 2 degrees, which means I've got an 8 degree decrease in temperature. You can feel it, it's cold. Yes, dear, you can.
Ma'am, is the bottle like what it would usually be?
Yeah.
Can I feel the bottle?
Yeah. So Diar's going to check the two as a comparison. You can feel how much colder it is. All right. So you can definitely feel how much colder it is between the two. I just need to sanitize your hands, my darling. All right. So what that means is we have an exothermic reaction. Heat's given off to the surroundings. Temperature increase. And please, we can pause now.